So today we're going to finish up with long division. This was an example that we did in class, but I just want to go through it one more time. It says find the roots of y equals x squared plus 10x plus 21. We know that x plus 3 is a factor. This could be divided with just normal factoring, but we're going to do long division. So here's how we set it up. X squared plus 10x plus 21 divided by x plus 3. We take the first number x squared and divide it by x and put our answer above, which is x. Now we're going to multiply this back. X times x plus 3 is x squared plus 3x. Notice you have to line them up. The x squareds have to be lined up on top of each other, and the x to the first power have to be lined up on top of each other. And then you just subtract. X squared minus x squared, they cancel each other out. 10x minus 3x is a 7x. And just like when we do normal long division, we're going to carry down the next part, which is a positive 21, and we're going to do this whole process over again. So 7x divided by x is a positive 7. I'm multiplying that 7 back again, so 7 times x plus 3 is 7x plus 21. Again, I subtract, so 7x minus 7x, it cancels. 21 minus 21, it cancels. There's nothing left. There is no remainder. So the roots of x squared plus 10x plus 21 are x plus 3 and x plus 7. And if we set this equal to 0, when y is 0, it crosses the x-axis at -3 and -7. Here's the second example from class, and we didn't have a chance to finish it, so there is a second part to this. It says find the zeros, and the zeros and the roots and the x-intercepts all mean the same thing. So we're looking at this and we're going to try and graph it. It says here that one of the roots is -2, meaning x plus 2 would be one of the factors. Okay, so we're going to line it up. X to the third plus 5x squared plus 7x plus 2 divided by x plus 2. We take the first term, x to the third, and divide it by x, and we're left with x squared. We put that on top. Now I'm going to multiply that back again. X squared times x plus 2 is x to the third plus 2x squared. Again, just like in the previous example, we're going to subtract. X to the third minus x to the third cancels out. 5x squared minus 2x squared is a positive 3x squared. Bring down the next term, which is a 7x, and we're going to do this all over again. 3x squared divided by x is 3x. Notice where we put our answers up above. I'm going to multiply this back again. 3x times x plus 2 is a 3x squared plus 6x. I'm going to subtract. Again, notice how everything's lined up. 3x squared minus 3x squared cancels out. 7x minus 6x is a positive x. Bring down the next term. I'm going to do this one more time. X divided by x is just a positive 1, so I multiply this back again and subtract, and nothing's left. So remember, when we're trying to find the zeros, we're letting y equal 0. So we already said that x plus 2 is one of the factors. The other factor is our answer, x squared plus 3x plus 1. And if I multiplied this through again, I should come up with the original equation, the x to the third plus 5x squared plus 7x plus 2. I want you to take a minute and solve this in the parentheses, the x squared plus 3x plus 1, meaning set it equal to 0 and solve it. Okay, hopefully you used the quadratic formula. It was not factorable, so either the quadratic formula or completing the square. And if you changed it all to decimal, you should get -2 from the first part, and from the second part, -2.62 and -0.382. If I graph this, here's what it looked like. And you can see the 3 roots, just like we found. All right, make sure that your notes are correct. It says 4x to the fourth minus 4x squared plus 6x divided by x minus 4. Again, we're going to set it up, and we're doing the same steps over again. 4x to the fourth divided by x is 4x to the third. I multiply this back again. 4x to the third times x is 4x to the fourth minus 16x to the third. There is a problem here, though. the 4x to the fourths are lined up, but the 4x squared and the x to the third is not lined up. So we're going to have to add something called the zeros into it. So the highest exponent, which is x to the fourth, we need a placeholder for x to the third, and then we need x squared and then an x to the first power. And you always need that. So if one is missing, like we have in our example here, the x to the third is missing, just add a 0x to the third. Okay, now we're going to do the same steps as we have in the past. We're going to subtract. 4x to the fourth minus 4x to the fourth cancels out. 0x to the third minus a negative 16x to the third is a positive 16x to the third. I'm bringing down my next term. And why don't you pause the video and try the rest of this on your own? Okay, 16x to the third divided by x is a positive 16x squared. Multiply this back again and subtract. 16x to the third minus 16x to the third cancels out. Notice everything's lining up. The x squareds, the x to the thirds are lining up. Tricky, be careful. Negative 4x squared minus a negative 64x squared becomes a positive 60x squared, bringing down my next term. This is the last time. 60x to the x squared divided by x is a positive 60x. I multiply this back again and subtract. Be careful, I'm subtracting a negative, and I have a 264x plus 0. Now, when do I know when I can stop? When I can't divide anymore. So in this case, I am adding one more 0 to it, and I'm going to divide one more time. I'm going to put a positive 246 on top, multiply that back again, and subtract, and I get an ugly remainder, 984. I would like it if you would put the remainder up on top, so it's the remainder divided by the divisor. So notice, because x minus 4 had a remainder, it's not going to be a factor. Okay, last one. We're setting this up just like we did before. Notice we have x to the fourth, x to the third, x squared. We're missing an x to the first power on top. On the bottom we have 3x squared. We don't have an x to the first power, so we need to add that. Okay, again, let's pause the video. Try this one on your own now that you have it set up. 18x to the fourth. Notice there's three terms that I'm dividing by, but that's fine. We're still just using the 3x squared. So it's 18x to the fourth divided by 3x squared is 6x squared. I'm multiplying the 6x squared back again. I'm multiplying it back by all three terms now. Then I subtract. Notice how everything's lining up. The x to the fourths are lining up. The x to the thirds are lining up. The x squareds are lining up. The 9x to the third minus x to the third is just 9x to the third. 3x squared minus 6x squared is negative 3x squared. I'm going to divide. 9x to the third divided by 3x squared is a positive 3x. When I multiply it back again, I'll get 9x to the third plus 0x squared plus 3x. I'm going to subtract that, and I need that 0x on top. So I'm subtracting a 0x minus a 3x. Doing this one more time because I can still divide. Negative 3x squared divided by 3x is just a negative 1. Multiply this back again and subtract. It's getting a little tricky. You're going to have to subtract some negative numbers, and you should have negative 3x plus 1 as a remainder. I can't divide any further, so that's how I'm going to write my remainder.